What is quantum spin? Subatomic particles such as electrons, neutrons, and protons move through a magnetic field and are deflected. They behave as if they're tiny little magnets, as if they have a plus pole and a minus pole. Now, in the classical world, a charged spinning particle has magnetic properties very similar to these particles. Physicists describe this behavior of moving through a magnetic field as spin, because they are using an analogy we are familiar with in the classical world to describe quantum behavior. So if we had a magnetic field, and we sent a particle through the magnetic field, what we would find is that the subatomic particle is deflected. Physicists describe this behavior of moving through a magnetic field as spin because they're using an analogy we are familiar with in the classical world to describe quantum behavior. Unfortunately, the analogy breaks down if you look at it too closely. The spin of an electron has only two possible orientations. So the electron moving through the magnetic field will have either spin up or spin down. Also, electrons, protons, and neutrons are not solid objects that can rotate in space. So the analogy only goes so far to be able to explain or describe the behavior of the subatomic particles. Two physicists, Stern and Gerlach, in the 1920s set up an experiment where they created a magnetic field and they shot particles, subatomic particles, through the magnetic field. And they were surprised to find exactly what we see here, that the behavior of the particles was quantized, or the spin of the particles was quantized. So the electrons behaved as if they were spinning very rapidly, producing tiny magnetic fields independent of their orbiting movement. And that was a shock. They were measuring the electromagnetism created by the electrons moving around the nuclei, but what they found is the electrons themselves were behaving as if they were spinning rapidly. The tiny magnetic fields created, called magnetic moments, were quantized, which meant that only discrete spins were encountered. And when we say discrete spins, we mean either spin up or spin down. Spin is the total angular momentum, or the intrinsic angular momentum, of a subatomic particle. When you measure the spin of electrons, they have half-integer spins, half-integer multiples of Planck's constant divided by 2 pi. So when they performed the measurements, they found that the measurements were discrete, and the same values occurred over and over again. So we've talked about the quantum spin of subatomic particles, and we've related it to the classical idea of spin. Thank you very much.